All right. This is voltage dividers. Now let's go ahead and take these useful equations first before we get into it. We have this power or watts equation, which is simply the current times voltage. We have Ohm's law, which can be rearranged into three different configurations. You have voltage is equal to resistance time your current. You can get your current from dividing voltage divided by your resistance, and your resistance is equal to your voltage divided by current. So as long as you know two out of those three values, you can do something with it. All right. This is what you have when you have a voltage divider. You have a source input voltage, you have an R1 resistor, you have an R2 resistor, and you have a voltage out that's between that R1 and that R2. So when you take the R2 and divide it by the sum of R1 and R2, you can get your voltage out. All right. So simple voltage equation. We can go ahead and take a 5-volt input reference. We can have a 100 ohm resistance for the R1. You have a 300 ohm resistance for the R2. And when you take your 5-volt reference and times it by 3/4, you get 3.75. Success. How do you remember this equation? It's a R2 over R the sum of R1 and R2. I like to think of it this way. So R1 is your top one. So it's always your bottom. So what is the voltage divider? I wouldn't recommend running a load on it. I mean, you can run a motor that adjusts the voltage output, but you're better off running that through a MOSFET. But let's say you have your car and you have a dial knob that allows you to turn it to set the temperature. So can you do that with a potentiometer? A potentiometer is a device that as you turn it from one end to the other, you have two resistance. You have one side that increases and the other side that decreases when you turn it. So it's a voltage divider. So you put in a signal, 5-volt reference, and you tie the other one to ground. You have this middle bad boy, and when you turn it, right, you get a different voltage. It's right in by the microcontroller. It can tell you what that voltage is. All right, here is our circuit setup. We have a input voltage. We have R1 and R2 are both variable. So R1 and R2 are inversely proportional in a potentiometer. So when you turn it all the way in one direction, as the voltage increase in excuse me, as the resistance increases on one, the resistance decreases on the other. So we can imagine a hypothetical scenario where we have R1, which is close to zero, and R2 will be infinity. So in this scenario, your V out is going to end up equaling your V in. Then you have this inverse scenario where you have your R1 is near infinity, and because we can't divide by zero, now let's set the R2 to 1. When you have 1 over infinity, your output on your V out is going to approach 0. All right. For this first test or setup, we're going to have this simple Arduino code that will take in this potentiometer. And as we adjust the potentiometer, it outputs a voltage. We have a simple analog read function that calls out the A0 pin. We assign that a variable, a sense VO, define a output variable called VO out. So we take that sense value, we multiply it by 5 volts, the reference voltage, and divide it by 1023. So this will output a serial print V out, and it'll display it in voltage. It'll give us an update every 1,000 milliseconds. I better correct myself on that one if it's wrong, but let's verify the sketch. Let's go ahead and upload it into the microcontroller. It's all done. Let's go over to the serial monitor. It's outputting 3.02. Now, our little bad boy over here shows 3.018. So our measurement is pretty accurate. Now let's adjust it. When we adjust the potentiometer, we can see that it clearly reads the voltage. Go all the way down, 0 volt, like we would expect. And go all the way up. So there's one says 5, one says 4.994. I think it's pretty accurate. So yeah, there you go. Now, potentiometer is not the only way we can actually use a voltage divider in our circuit. Another option is, let's give a good example. You're at your home, you have your thermostat. You have a little device, you have a little component that changes the resistance with your temperature fluctuates. It might go up when it gets hotter, or it might goes down when it gets hotter. I've seen both. So how can we actually utilize this? Here we got a typical voltage divider circuit, but this time we know what one of these R1 is. We know what the voltage input is, and we also know what R1 is. But the thing is, we don't know what R2. So this can vary depending on how hot or how cold. We can actually make a determination based upon this. And to make this useful, we simply have to solve for our unknown. So in this case, we don't know what our R1 is. We know what R2 is. I get this back. Dang it. Okay, we're back. So we're going to have to solve for R2 here. In this example, we already know what our V in is. We can read our V out. We know what R1 is. So based upon all those three, if we solve for R2, we know what that resistance is. From there, we can make a determination on what that value is and calculate a temperature based upon that. This next sketch, we're going to take the known value of R1 and we're going to calculate the unknown value of R2 right here in the code. Right in our variables in the void loop, let's go ahead and just write those in the setup. We call out R1 as well as R2. We set our R1 to the value that we know. So that's going to be 327. That's not going to change. We do our void setup. And then finally, we read our analog voltage on A0 pin. And then we go ahead and calculate what that value is. Now we take our voltage divider equation, solve for R2, and this is what they give. Can calculate R2 with this equation. So we got everything else we need. And this will serial output print on the voltage that it thinks it is, as well as the actual voltage that we read. And let's verify it's done compiling. And let's execute this script. We're saying that it's 0.14 volt digital multimeter. We're reading 146 millivolts, and it thinks it's 10 ohm, it thinks it's 9.2 ohm resistance. Let's go ahead and pull our resistor and find out what that value is. So it's showing 8, 9.8. So I think it's pretty accurate. It's about right there. We can also utilize the voltage divider when we know what our input voltage is, when we know what our R2 value is, and we can read out that voltage output. Believe it or not, this is how most devices calculate current. They don't actually calculate current. They calculate a voltage based upon a sense resistor. And from there, you can determine what the current is of your circuit. So, like here, when you make a current measurement, you plug it in through here and it tells you what those outputs are. Now, the voltage, excuse me, the resistor on this device is really small. And it's also and then also that it needs to be magnified or amplified. We're not gonna go into that here, but for our purpose sake, it's like, yeah, it's a use for a voltage divider. All right, this is our simple setup circuit. We have a V1, we have an R1, which is unknown, and we have an R2, which we're going to go ahead and set to 100. And if you like this content, please like and subscribe for more. All right. For this one, we just solve for our R1. We're going to know what our input voltage is. We know, or we can measure what our output voltage is. And we know what R2 is. So all we need is to solve for R1 as shown on the screen. Well, let's get into our microcontroller example. Okay, we're going to find out what R1 is on this setup. We know that our R2 value is 100 ohms. So we're going to go ahead and set that. We're going to just go ahead and go through our calculations to determine what our V out is. And then we're going to use this R1 code, and that's going to calculate what our unknown value is. In addition, we can calculate the current for this. We're going to call out our 5-volt reference. We're going to divide that by R1, our unknown value, and then we're going to multiply it by 1,000 so that way we see it in milliamps instead of amps. This whole entire code executes that, calls out what the resistance of R1 is, what our V out, and also our milliamps. Check this code. It's good. And let's execute it. All right. And we're getting our readings. It says 157 volts, 22.86 milliamps, as well as about 218 ohms. Well, let's verify this with a digital multimeter. 1.56, they read the same. That's good, right? And now finally, let's go ahead and pull our unknown resistor and let's see what it tells it is. All right, we got 217. And when we compare that to our calculated value, it, it told us that we were right there. It said 218. We got 217 on the multimeter. Hey, it's just about right. It's close enough.